Thank
Musonda.
you, Samaria, and thanks for the rest of the colleagues to come here and listen to this presentation. So our topic is algorithmic discrimination and responsibility, and we took some selected studies or case studies from the US and from South America. Um, so my name is Musonda Kapatamoyo. I'm a professor at Southern Illinois University in Edwardsville in the US. And I co-wrote this research with two colleagues of mine that work in Ecuador. One of them is Professor Elisa Ramos Gil, and the other is Camelo Marquez. They work in Pontificia Católica University in Ibarra in Ecuador. So basically, we're going to talk about the following things. Um, as far as algorithms are concerned, we shall talk about creator bias, because as we know, algorithms now are used for different things. For example, surveillance, social profiling, or business intelligence. Surveillance could be, good or bad, just depends. But there's all kinds of surveillance. For example, just following people around, seeing what they're doing, um, from cameras, from use of social media, from the internet searches, and things like that. And then social profiling is about putting people in categories and patterns, and then using that data for whatever purposes you want. In this case, the examples we shall give are about predictive policing. And then business intelligence is what corporations are doing, looking at which people are participating in their products, the best customers, the bad customers, who's likely to default, and things like that. And using that data to make better decisions just for their business. We used the framework that was first developed by Lawrence Lessig in the 90s, but it's even more applicable now with what's going on with algorithms. And the framework basically spoke about computers or computer systems as laws unto themselves, meaning, people are going to understand this as something they have to do because of the application that they're into. And then how markets affect the diffusion basically of these systems, and then the codes. The code can either discriminate or include, depending on how it was written. And then, of course, social norms being stuff that people basically understand about themselves as required in the interaction with society. So I'll go into more details about that. And then some case studies and some conclusions. So, what is an algorithm? We're going to go into what algorithms are doing. So far, as we've seen in this conference, we've learned and understood that algorithms are playing an ever increasing role in our daily decisions. And I just gave a few examples in the last slide about social profiling, business intelligence, and surveillance. Um, the reason algorithms are so important and so prevalent is because of automated decision making systems. And these computer systems that have learned how to, use data given to them, and then through machine learning, are making decisions. And they make decisions for all sorts of, um, in all sorts of sectors. Um, However, those decisions can have an impact on society. And one of the negative impacts that we see the most is discrimination. And discrimination is easy to notice because it affects somebody immediately, and the person actually knows they're being discriminated against, and the person that's doing the discrimination probably knows they're doing discrimination because of the information that they have in front of them. So, what an algorithm basically is it's a process or a set of rules that are used by computers in calculations and other problem-solving problems. I chose this very basic description by CV and Kenny because it basically tells you that an algorithm is going to do the same thing over and over and over and over again, depending on the set of rules that it was set up with. So if it was told to do A, it's going to do A very well. If it was told to do B, it's going to do B very well. And there has to be a human agency at some point to recalibrate that algorithm so that it can do C. So algorithms are very efficient in terms of solving problems, but very, very quickly. And that's how come they are now in everyday applications for us. One thing we also found is that people do trust the machine. People trust computers. Um, and the trust is for me is easy to understand because of like what we've seen in some of the presentations here. People are alluding to things like the black box. What the black box basically is it's opaque. You can't really see what's inside of it. You don't know how the algorithm was written or the computer code was written, and in most cases, if it's not open source, then you're not gonna know because the people that wrote the code, they're using it for as a business for revenue basically. So that's their thing. They're not going to just give it to everybody, and that could create a problem. Um, but people do trust the output. You press delete, you expect the file to be deleted, and people think it's deleted, but actually it's not deleted. It could just be put in another file or folder. So simple things like that. But basically, decision making by use of algorithms is going to follow the following processes all the time. The first one is once presented with data, there's going to be prioritization. So prioritization is ranking 1, 2, 3, 4, 5 in that order. And then there's going to be classification. So within those ranks, the data is classified into categories. I like to give examples of if we're doing demographic data. We talk about children. Okay, who are the children? There's boys and girls, and then young people. Who are the young people? There's this age or teens, boys and girls, and then adults. And then within that, you could say some classifications. I mean some associations. So you begin to associate what's the association between the children and the adults, between the men and the women, between this characteristic of people with this other characteristic of people. So you begin to see networks of people. And then the last process is filtering. So basically, this is a process of either including or excluding. So when you're doing filtering, you're saying this is not important, that's not important, and that's important, and that's important, based on the things that you worked on during association, and then classification and prioritization. So algorithms are doing this fast, like really super fast, and it takes away the effort from people to do these things. Because if we were doing these things ourselves, it would take 1 week, 2 weeks, 1 month, who knows, just depending on how much data you're dealing with. So algorithms are good, in my view, for them to do these things so quickly, but there could be a problem down the line, as we shall see. The problem could be something that we call dirty data. It's a common phrase in the US actually, um, but it refers to data that's bad, data that was either input wrong, or the data that was collected wrong, or data that was just misapplied, data with missing variables, a lot of open spaces, and just all sorts of data that could be deemed as not very suitable or not very clean. So that's dirty data. When you use that dirty data for machine learning, the machine learns on that data, and it uses that data to make automated decisions, which in the end people trust. So you see the direct link there from dirty data or bad data to all the way to automated decision making. But it might have implications for social, economic, political aspects of individuals, and all these can affect fairness, equity, and justice. Um, the way that we as society are dealing with this problem is different depending on where the problem is. Um, for example, in Europe, you guys have been discussing the GDPR, which is a General Data Protection Regulation. And in this one, there's a specific chapter about algorithmic discrimination. And it lists the characteristics that should not be discriminated or should be not used as a basis for discrimination. For example, racial or ethnic origin, an algorithm cannot be created to specifically target these as points of discrimination or political opinion, religion, or people's beliefs, trade union membership, genetic and health status, and sexual orientation. And these have all implications for an actual person, an actual individual. If they're discriminated against for any of these, they might lose out on social status, on social programs, on employment or health outcomes or stuff like that, or even insurance. So it's a big deal. And the organizations that rely on big data, that are using algorithms to make automated decisions, should be mindful that that algorithm might have, uh, through filtration, might have included one of these aspects as a point of discrimination. So we have to watch for that. So we thought in our paper that this was a good piece or point of departure from the GDPR. One of the problems that we see with predictive with algorithms is an example is predictive policing. So basically, predictive policing, which should really work well, but basically it's a use of systems to analyze available data to predict the location or the time, the type of individuals involved, and so forth that will likely happen. And then once that prediction is made, resources are sent there to go and try to mitigate that problem. So this could be like physical police presence, police cars, just money, or programs that are created to try and solve this problem. But if you see that clear line from bad data being used in automated systems that create an output, and then that output is given in front of an officer to go and enforce this solution, they might be just addressing the wrong thing. So what we've seen in different examples in the United States where police departments have been accused of social profiling. And they'll say, oh, we just follow the data that said this type of person is more likely to be engaged in this type of problem. So that's why we went after them. And then you create a feedback loop, because that becomes data that's, again, put in databases that puts into machine learning processes, and machines learn that data, and they spew out the same kind of output that's used in predictive policing. But believe it or not, predictive policing is used a lot, and a lot of departments across the country have bought into different platforms that they buy, that some are white labeled specifically to the department, others are kind of off the shelf, and then they use them to create internal processes for predictive policing. Same thing is used in South America. So we have examples from Ecuador, from Argentina, where predictive policing is used with a view of trying to solve a problem before it happens. But the same issue does arise, like where did the data come from, who's using it? So that's subjectivity might be a problem. So what we came up with as ways to solve this problem, and what we're calling as responsibility, is the following. First, laws. We need good laws, and those laws have to be transparent or force transparency, and we need accountability on the part of people that actually make these algorithms, and then we need sanctions. So laws are important. The next one is social norms, also are important, and social norms kind of force or regulate compliance, and there's got to be a normative structure for that to happen. The third is international treaties and legitimacy. So the reason we came up with these is basically to fall back on the framework that I spoke about, that Lawrence Lessig actually came up with, and we just expanded it. So as far as laws, we are advocating that there's got to be transparency or agent transparency in an algorithm. But we've already said that algorithms are black boxes for the most part, because they're created for a purpose of solving a problem, and they are proprietary to the organization that made them, right? However, If there was more transparency, then we would know that there was no probably greater bias in the way this thing was made, and we can start to begin to trust the output a bit more. And then accountability is basically forcing accountability on the part of the people that create these algorithms. So right now there's a law in the U.S. Congress called Algorithm Accountability Act, and some of the people that are in front of it basically are now running for president. So they've taken a back seat, and probably to happen when they're less busy with the campaigns. But what the law is advocating is accountability, meaning that the person that creates an algorithm must know that if something bad happened, then they should be held accountable. And this does happen across other industries. You know, if you're a car manufacturer and you make a car with bad brakes, you know, somebody dies because the thing malfunctioned, you are liable to that. You know, you're held accountable. So why can't we do the same for algorithms? And then sanctions. Sanctions basically mean sort of not like a punishment, but a way to exact some is a sanction uh, punishment. If you do something bad, yeah, you know, we tell you to either pay a fine, you go to jail. I mean, within the continuum of solutions that can be applied, but there's got to be a sanction. And then social norms basically lead us to compliance. Um, Compliance here can happen different ways. Um, Number one, it could happen when people feel like shamed into um, admitting that they did the wrong. So once they do that, then they'll never do it again, or they'll stop doing it again. Um, it could also be with peer pressure among us, the peers. So there's correction. If somebody says, "Oh, your product is wrong," and they have credibility to criticize, you kind of take that and use it. It could also be with laws, the laws that are created to make sure that people follow certain guidelines as far as when they're giving out or when they're rolling out the algorithm. And we could have gone into, I think, ethics as well here a little bit, but maybe there's already like ways that computer ethics apply to people that do algorithms. And then normative structure is a structure that allows for people to follow what their society at that point is allowed to do. And then meaning the social meaning that is favored or disfavored by that society. That's what the normative structure does. Then the third one, international treaties is important because these technologies are going across vast lands, you know. So they're made in a, for example, in Madrid, somebody creates an algorithm and it works here, and they want to sell it. So they have to sell it to a company in Zambia or to the Zambian government or Ecuadorian government or whatever government or wherever. However, whatever implicit biases were inside of that algorithm are going to go with that algorithm in these different jurisdictions. But how do we begin to protect the people in different areas? So that's where international treaties come in. So the GDPR is actually a good start, but there are other organizations that also look into these type of things, and they're able to protect individuals in different places. And then legitimacy is just basically the threshold at which point an algorithm begins to get credibility. And the better it is, the higher the rank that it gets, then it gets more legitimacy in terms of people believing that the algorithm was written with the idea of being more responsible. So, in conclusion, what we came up with the following as ways to basically increase algorithmic responsibility. One, there's got to be controllability, meaning that people should have the ability to control that algorithm. We already said that algorithms are used in machine learning, and then that feedback does come back to feedback does come back to the people using the algorithm, whether it's good or bad, and that should be applied in making sense. And then responsibility on the part of the creators. Um, it's got to be implicit to the person creating an algorithm that they are responsible for the outcomes that, especially in automated decision making, that are made as a result of the algorithm that they wrote. And then responsiveness is basically the ability to change it quickly, and transparency, which has been a problem, uh, ought to be looked at for the most part, because if people know how what's in the algorithm or how it's written and for what purpose it was written, then there's more chance that um, it could be improved. And then the last one is sense of liability. So here we think that people, most people are inherently good, but some are not. And if there's a way people are made aware that they're going to be held liable for a bad product, then maybe that could actually help. So we have to, I guess, begin to think of algorithms as a good tool to use, but like every good tool, maybe it can be abused, and they could be created with some implicit bias, either just biases that uh, basically advantage the people that made them and disadvantage other people, given the characteristics that, for example, the GDPR does identify. So, in a nutshell, this is our presentation, just making some recommendations about how we can improve algorithmic responsibility. Thank you.